Hey, long time no see. In this one I wanted to show you what polymorphic executables are, and besides their fancy names, they're actually very simple and useful in some certain situation. So let's say I have a script called foo. Here, just a regular shell script. You can do this in every single programming language you want that accepts arguments, which is all of them. And so what you may know is that in shell you can have $1, which is the first argument, $2, which is the second argument, and of course $0, which is like the first argument, which is the executable's name. So in C you have argv0, which is also the executable's name. And so far you've been maybe using it in, like, let's say error messages to say, oh, executable name $2.error and then the error name or something like that. But there is a neat trick you can do to, let's say, optimize binary size, or if you want multiple commands into one executable, you can actually switch on this first argument, which is the executable. So let's say I want to switch on $0 like this, and for now I will just have foo, and I will say hello from foo, something like this, and then we break, and then we do Ozak like so. And so if we do foo like so, it says hello from foo. And what we could do is, let's say we would want multiple commands into this file. I could say if the program names is foo, do this. If it's bar, do hello from bar. And if it's buzz, like so, oops, buzz, do print something else again. And you might be wondering, okay, but this is always gonna print foo. What are you on about? And the thing, the little trick you do to have a polymorphic executable is you create a symbolic link from foo to buzz and from foo to bar. And now if you look, you have two links that point to the executable foo. But if you do bar, now the first argument of the program is bar, and so you can change the behavior of this executable, and same thing for buzz. And now you might be wondering, okay, that's a neat trick, but where is it actually useful? And the most, I think the most obvious example where I've seen this is in the Alpine Linux distribution. So Alpine is a distribution that is meant to be very small. It's used in like clustering application, and whenever you want to spin up a lot of services, you don't want them to have a huge distribution like Debian or Red Hat or anything like that. You want your thing to be snappy and your container size to be as small as possible. Well, let me run a container of it. And so it has like the basic, Alpine has the basic Unix utilities that you would find. So cat e dev shells, let's say, or something. Anyway, it has ls, cat, everything you expect. But if you look at where those executables are in bin, and you do L, you might find that every single one of the standard executable are actually symbolic links toward bin busybox. And busybox is just, you know, on GNU Linux you have like core utils, which is developed by the GNU guys, which like has a lot of Unix utilities in it. And busybox is just another variant of that, and they are also POSIX compliant, but they focus on having a small binary size. So it's often used in distributions like this, or on embedded systems, or stuff like this. And so you can see that they use this polymorphic executable trick here to log, for example, hostname will just link to bin busybox. And then the binary busybox will just look at argv0 to know which command it needs to execute. So, and you can actually do run the executables itself, and then here you have to pick one. So this is the obvious example, but one other instance where I've used it personally is to, so I have a Git server somewhere, and there is this thing called Git shell. I will link to a very old video where I show this, but basically it's like a shell that if you have a Git user on your system, you can set that Git user to have the Git shell as its shell. And so if you SSH into it, you can basically pick the commands that this user can use. And so you can you can restrict what the Git user is able to do. And so you would like, if you have a Git server, you would like that whenever you log in via the Git user, you would like to be only able to create a repo, delete a repo, list the repo, this kind of things, like basically edit Git related stuff, but not touch at the rest of the system. Anyway, I've made a script that does just that. So the script is just called repo, and there it has multiple commands, for example, create, delete, publish, or list public, this kind of thing. And here you can see that I have a command variable here that is basically, it uses $0 and it parses it in some way to extract the command from it. And then I just have a case to that command. And so what happens now if I log in into my Git server, you see that first of all, this is not a regular shell. So if I try to do ls, it doesn't exist. If I try to do cd, it doesn't exist. But if I do list, it will work because I have created a symbolic link from the list thing to the repo script. I mean, let me show you that. Okay, so I logged in into my server via another user to show you, because of course, if you have the Git shell, you can do anything. So so here I'm in the home of the Git user, and you see that I have the git shell commands thing. So if I do in this directory and then lsla and put this full screen, you can see that I have the repo executable script that I just showed you, and every single command, every subcommand, let's say, is just a symbolic link to this script. And so that's why I can do list directly, or I could do any of those, like create, delete, whatever. So anyway, that's all I wanted to say about polymorphic executable. It's yeah, just a neat trick. I hope you enjoyed the video, and see you in the next one.